Hey everyone, this is the Learn Lab for testing your Terraform configuration. I'm just doing a little bit of window setup here to make sure I am all ready to go for you. Before I even jump into introductions, I'm actually going to bring up this slide here. If you're going to be following along today, which we not only welcome but encourage, you'll need a few things. You'll need Terraform 1.6, just came out last week, so make sure you're nice and updated there. I think 1.6.1 just came out like yesterday. I'm still on 1.6 because demos, but as long as you're there, you're good. You'll need an AWS free tier account, and there's a couple places you'll need your credentials. You need to authenticate you'll need to authenticate Terraform locally with those credentials, so we'll be running some Terraform commands that will be actually deploying some infrastructure. And then we're going to put those in Terraform Cloud as well, so make sure you have a key pair either ready to go or have that handy to generate. You'll need a GitHub account and a Terraform Cloud account with your GitHub account set up as a VCS provider. If you don't have that, I think if you go into your organization settings, VCS provider, it'll walk you through the steps to go through that. While you're getting situated, I did want to introduce myself and just kind of call out the TAs again, because I really appreciate them being here. So I'm Brian McClain. I'm a education engineer at HashiCorp, focusing on Terraform. We do have Robin, we have Andrew, I believe Omar will be joining us or may have joined us. If you have any questions, if you have any issues, like Justin said, raise your hand for the TA. I like that idea of maybe a thumbs up for a question. I'm gonna be taking a couple breaks for questions as well, just to let people catch up if they've fallen behind a little bit. And what we're gonna be going over today is we got a few slides to get through. A lot of them are code examples at least, but we're gonna set a little bit of context, talk about the new test feature, how that fits into some of the features of Terraform. We're going to go over the new testing syntax, which is, I think, a fairly deep dive into it. We'll see how to write those tests and all of the options that you have to write them. And then we'll get hands-on with the workshop. We'll start running some tests. We'll write some tests. We'll check out some of these new features. So while you're getting set up, I did want to set a little bit of history with this, because as I've had conversations with people on this new testing feature, one of the things that inevitably comes up in that conversation is, well, how does this relate to this feature or that feature in Terraform? And it's always around what we usually refer to as the validation features. If you're not familiar with those, there's three in particular I had in mind. So in 0.13, Terraform introduced input variable validation. And this was a way to ensure that your inputs to your variables meet certain requirements. So things like, is this string of this length, or is my instance count variable greater than 0? In 1.2, Terraform introduced pre and post conditions, and this was a really cool feature. What this lets you do is create custom rules for resources and data sources. The example I like to use here is you're deploying an EC2 instance. You don't know the AMI that you'll be deploying at the time of writing your configuration. Maybe it's user provided. You could write a precondition that would check, is this the right infrastructure? Is this the right architecture? Is this the right type of AMI? And if not, let the user know and how to fix it. And then just recently in 1.5, Terraform introduced check blocks. And that moved that custom logic of being able to write these custom conditions for validation out to its own top level block named the check block. And what this really intended to do was give you a way to validate your infrastructure as a whole. So I deployed my compute, deployed my storage, deployed my networking, apps up and running. I could write a check block to maybe go out and send a request to that application, make sure it's responding as we expect it to. But we refer to these features as validation and not testing, because they're not really testing. They're more like error checking for your configuration. Right? These are errors that the consumer of your modules will see. They're errors that should probably be actionable by the user. If I give a instance count of -3, I should probably tell the user, let's try a positive number. Whereas tests really look to fill that need for unit and integration testing. I give you these inputs, I expect this output. If I have these values for my variables, it should build this infrastructure. And that's not only useful for when you're initially building that configuration, but as you update it to 1.1, 1.2, 2.0, making sure that all of these assumptions that you've made when you've written this configuration initially still applies today and you haven't broken anything. So that was my little history lesson on what brought us to today, which is the new feature in 1.6, Terraform test. And the end goal of tests is really to test your behavior and the logic of your configuration. Not really any individual deployment of a particular instance of your infrastructure, but rather, okay, if I give it this logic, am I given this infrastructure in the end? This is built into the Terraform configuration language, so you're writing your tests in HCL or in JSON. They live right next to your configuration, so we've introduced the tftest.hcl file extension. It's a really great way to make sure that you're differentiating between tests and your config, and of course the new Terraform test command. When you run this, it'll actually go out, it'll build infrastructure, it will test that infrastructure, but this is separate from the plan and the apply command. This is its own life cycle. Because the goal of tests really is to give you this opportunity to run it over and over again as you make your changes. And as that infrastructure gets deployed, Terraform will keep a separate state in memory as it's running. So if you have a deployment of your configuration, you want to test out some different changes, you can run this safely without making any of those changes until you're happy with them. I'll just skip the slide. So today we're going to take a look at some of this syntax, start writing some tests, and to do that, I want to ground this in a concrete example. For this example, I have a very small module. It's going to deploy a static website. It's going to do this by deploying an S3 bucket, deploy a couple HTML files as objects. It's going to configure it to be publicly accessible and to host a website. And it's going to define one variable and one output. And that's going to be important for what we see a little bit later on. The variable name, bucket name, which, as you might guess, is the name of the bucket we'll deploy. And then our output is the website endpoint, which is the full URL. Once you've deployed our configuration, the module consumer will know where to go to see the website running. And to just get into it, this is kind of a general overview of what a test file looks like. I've subbed out a couple things just for the sake of fitting everything on a slide. But we'll go through these one by one. We'll look at some examples. But more or less, this is what makes up an individual test file. I'm going to say this about a few things, so I apologize in advance. But you can have multiple test files. When you run Terraform tests, by default, it'll look in both the root directory. And if you have a directory named test, it'll look there as well, and run them in alphabetical order. So let's just start at the top. We'll go through this. And we're going to start with the first block here, the provider block. Now, this is optional. If you don't provide this, it will actually use the provider information defined in your configuration that you're testing. But in this case, I said I want to run all of my tests in US East 1, no matter where my configuration is configured to run. And right away, there's a couple of use cases I want to highlight here, because I think they're actually really cool. First is overriding some of the provider configuration. So in this case, in this first example at the top, what I've done is I've overridden the default tags of the AWS provider. And every piece of infrastructure that gets created with my tests, in this case, will have the environment tag with the value test, which makes it super easy if I want to go through and audit my infrastructure in AWS, just to see what's been used for tests versus maybe my actual production environments or development environments. You can also have multiple provider blocks, like you can in your configuration, and you can do this using the alias field. So the second example I have here, I have the alias secondary, and whenever I configure my test to use this provider, it'll run it in the EU Central 1 data center. So in this case, maybe I want to run my test in multiple data centers just to see is the behavior the same from data center to data center. So a lot of cool things you can do with that provider block. Let's jump back to our overview, and we have the variables block. So here, we're giving a value to that bucket name variable for the configuration that we're testing. This is optional. If your module doesn't have any variables or you're fine testing it with the default values, you can actually completely omit this. You don't have to include it at all, just like the provider block. But in this case, we wanted to say for all of our tests that we're going to run, set the bucket name to test bucket. And then finally, we have the run block. And this is kind of the heart and soul of our tests. This is where all the logic of our tests is going to live. Just as I said, you can have multiple test files. In each of those test files, you can have multiple run blocks, and they'll run in sequential order. Here, I have two run blocks. I have one named create bucket and another named website is running. Let's just jump into that first one, and we'll see an example of a run block. So there's a lot going on here. Some of this might look familiar, especially if you use some of the other validation features of Terraform. But we'll start at the top and, again, just kind of work our way down. And first, we give it a name. So we're naming this create bucket. There's a couple times this name will be referenced, but most predominantly, this will be when you run your tests. It will say running create bucket passed, hopefully, depending on how the Wi-Fi is today. Next, we have this command field. And this, if you pay attention to no other part of the run block, this is something I really want to highlight and drive home. Every instance of a run block is translating to an actual plan or an apply that's happening on the back end. So if we want to do something more like integration testing, we actually want to deploy something and see what comes out the other side, we can run an apply. If we just want to test some of maybe our validation logic or something that we know at plan time, we could run a plan. By default, if you omit this, it'll run an apply, but I've included it here just for the sake of being explicit. But you can also do a plan or a refresh-only plan. If we keep working our way down, we have the second time we can define a variables block. And what's going to happen here is the most locally scoped variable block wins. So in this case, even though I've said at the top level of my file to give the bucket name a value of test bucket, here I'm saying for this particular run block, give it the value of AWS S3 website test. So if you have some values that are fine for like 90% of your tests, but you have a couple that you want to kind of tweak those values, this is a really good way to do that. And then finally, we have our assert block. And this is where the actual logic lies. Again, if you've used things like pre and post conditions or check blocks, the syntax looks a little familiar, but if not, there's just two fields per assert block. We have our condition. In this case, we are comparing the e-tag value of our S3 object, which will end up just being the hash of the file computed on the S3 side. And we're comparing that to the MD5 hash of the file on my local disk. So basically just testing, did this file get uploaded correctly and in one piece? If that condition evaluates true, which hopefully it will in our test today, great. This assert passes. There's no other asserts in here, so the run block passes, and we're happy. If it fails, though, the run block will fail, and this error message will be shown. In our case, invalid hash for index.html. Now, just to kind of work from the outside in, you can have multiple assert blocks. So for each file, you can have multiple run blocks. For each run block, you can have multiple asserts. To go the other direction, for the run block to pass, every assert block has to pass. And for the file to pass, every run block has to pass. So kind of a two-way relation there. So far, we've run our first test. Awesome. We're making sure everything gets created and uploaded appropriately. But we're only really dealing with information that we know at the time of a particular plan or an apply. We know this information either just kind of inherently from our configuration or information that we can maybe calculate at the time of a test. But there's certain times we might need more information. We might need test-specific resources or test-specific data sources. So for this next test, what I want to do is I want to test, is my website up and running? Can I send requests to it? What's the response code? And what we're looking at here is a test to do exactly that. And one thing to highlight here is this new block we're introducing, at least for a run block, which is the module block. So the module block is saying basically, instead of running the plan or an apply, and instead of running all these asserts against our main configuration, the configuration that we've been testing so far that's creating the bucket, run it against this module over here. In our case, we have a local module in our source control set at test/final. And if we take a look at that source code, we can see it's a fairly small Terraform module. Nothing special here. This is, you could actually just use this out of the box today. What we're doing is we are pinning our HTTP provider version to 3.4.0. We have one variable named endpoint, which take a note of that because we'll have to give that a value. And then we're creating an HTTP data source. If you haven't used HTTP provider or data source before, This is a really great way to send requests out to a specific URL. A whole lot of fields that you can use to customize this, but in this case, we just want to send a simple GET request to that endpoint variable. Let's hop back over to our test, and we have that variables block again. And let's pause and think about the situation we're in now. So in our previous run block, we created our bucket, we created our state. We want to reference an output from that. So we can reference an output from a previous run block with this notation that we have highlighted here. We can say run dot block name, in our case, create bucket, dot output name, or in our case, that website endpoint output that we talked about a little bit earlier. And then we have our assert block, which will do the assertion against this helper module. In our case, we are taking a look at the status code property of that HTTP data source, checking to make sure it's 200, to say everything's okay, it's responding to requests, and if not, it will say invalid HTTP status code. Now there's one more kind of feature of tests that I want to point out before we start jumping into running some of these and writing some of these, which is the use case where you may expect failure, kind of explicitly expect failure. In fact, you want it to fail. A good example of this is input variable validation, right? If I put some parameters around an input variable, I want to test to make sure, is my logic correct? That's not something inherent to Terraform, that's something I've provided, so I want to write a test for it. So for our module, we have this variable defined, the bucket name variable we've been referencing so far. So we have a description, we have a type of string, it has a default value of null, and then we have our validation around it. This isn't a part of 1.6, by the way. This is the standard variable validation that's been in Terraform for a little while. But you can see it's a very similar syntax. And what I'm saying is I want to check the length of the bucket name variable. If you're not familiar with S3, bucket names have to be between 3 and 63 characters. So being good module developers, we decided to put some validation around that so it would give a nice user-friendly error in case the user gives a invalid bucket name. So if we look at the test to test this, we can see we're just going to do a plan because this is something that's evaluated at the time of a plan. We're going to set that bucket name to A, so should fail that validation. And then we use this expect failures field here to say this should fail. And in fact, if this doesn't throw an error, this run block will fail because I've explicitly said this should cause an issue. You can use this expect failures field with anything that you can put a custom condition on. So if you're using variable validation, pre and post conditions, you can validate that logic with this feature. Okay, so I've spent a lot of time on some of the hypotheticals. Let's just start getting into the workshop. Let's talk about what we're going to be showing today. And what we're going to do is we're going to take this module we've been using, that static site module deployed on S3. It comes with a test, which is more than, I think, a lot of code bases that I've worked on, so great. We're going to add a new helper module, a new test. We're actually going to build out the exact test that we just saw to test that the website's running. So if some of the mechanics of the helper module relation that we just saw is a little not super clear yet, we'll see that in action kind of top to bottom. And then we're going to take that module, publish it to Terraform Cloud, and show a couple ways that we can run our tests remotely in Terraform Cloud. If you're following along, which again, we encourage you to, I would go ahead and bring up this URL here. This is the written version of the tutorial that we're going to go through today. There's a couple code blocks we'll be copying, a couple commands we'll be running that'll probably just be easier to copy from the tutorial. There's also a link to a GitHub repository that we'll be cloning to start our test with. If you're not running it, we have a QR code, goes to the same URL. Bookmark it, check it out later, maybe at your own time. I'll leave that up for a second while everyone's getting situated. Were there any questions so far on what we've seen, just along the lines of the syntax or maybe questions about the feature? Like I said, we'll get into actually running it and writing some of these tests actually right now. Awesome. I'll take no questions. Cool. So let me bring up the tutorial here. This is the same tutorial that I just linked to. This is up on developer.hashicorp.com. And I'm going to scroll down and find this template repository that we linked to. Open that up. And this is a kind of a starting point for what we're going to be doing today. So we'll use this as a template repository. I'll create a new repository. I will choose myself as an owner. And we will call this Terraform AWS S3 website tests. If you haven't published modules to Terraform Cloud before, this is kind of the standard naming convention, by the way. This Terraform dash provider name. I just realized it's a little small. I apologize. So this Terraform dash provider name, since we're deploying on AWS, we're using AWS provider. It's dash AWS dash module name. So the actual module will be called S3 website tests. I'll keep it as private and create the repository. Should just take just a moment, depending on how the Wi-Fi is feeling today. Cool. So we have our own repo now. We have our own copy of this. I'm going to take this and make that a little bit bigger. I'll clone this down to my machine. Change into the directory. And I'll open this up in my text editor. Let's get a little bit more screen real estate here. All right, so let's just take a look at the configuration that we have here, and then we'll dive into the tests. We have our terraform.tf file. This is going to be we're defining our providers. In this case, we have our AWS provider. We're pinning it to the 5.0 release. We have our variables file, and this is where we're defining that bucket name variable. I've just went ahead and omitted some of that validation just to keep things as simple as possible for this workshop. We have our outputs file, which is defining that the website endpoint output. Again, the URL to the website once it's up and running. And then we have our main.tf file. And here's where we're deploying all the resources for our static website. So we're creating the bucket. We have a number of S3 specific configuration resources. So we're setting up to be a static website and telling it what's the index document and the error document. A lot of permission stuff, which it's AWS, so there's always going to be permission stuff. A recent change to S3, by the way, I think you actually have to explicitly say, yes, I want to be able to have open permissions on this bucket. So that's what this bucket public access block is doing. And then just setting up the ACLs and the policies to make that publicly accessible. And then finally, we have two S3 objects to, don't want the dictionary. We have two S3 objects to upload the files into the bucket, our index file and our error file. And these are both coming from the www directory inside our repository, which we can actually see right here. Cool, so that's fairly standard Terraform configuration. Let's take a look at the tests. And here I have two run blocks to start out. I have our first setup test run block, because if you are an S3 user, one thing you might have already gotten ahead of me on is bucket names also have to be globally unique. So I'm going to go out on a limb and assume that the bucket name test bucket's already taken. And I've developed a helper module that will go through and generate a random bucket name for my tests. Even if we did have a very random bucket name, but it was hard-coded, you could probably imagine if multiple people are running these tests, automated testing, there's a really good chance for an overlap. So we'll just randomize it every time that we run this test. We have that module block again to say, instead of running our apply on our configuration, run it on this test. And we can see it's pointing to the test/setup directory. So let's take a look at that configuration just to be complete here. And just like the example helper module that we saw previously, we're using the random provider. We're creating a random string to be our bucket prefix. And then we have one output at the bottom here named bucket prefix. let's go back to our tests. And we have our other run block, which is that create bucket run block that we just saw previously. So again, this run block will actually go out, it will create a bucket, it will upload the files and configure the website. For the bucket name, we're seeing that same notation to reference the state of our previous run block. So doing this run.setuptest.bucket prefix. And then we're using string interpretation to put a suffix on there of AWS S3 website test. So some cool things you can do with some of the built-in functions of Terraform as well. And then we have, in this case, 3 assert blocks. Our first assert block will just make sure that the bucket name matches what we gave it. And then we have 2 assert blocks to check the etag property, again, the hash of the file calculated on the AWS side against the file on our local disk. So just checking, did the files get uploaded in one piece? So I think we are in good shape to go ahead and run this. All right, so we have our configuration, we have our tests. Let's go ahead and run this. And hopefully this works. We'll use the Terraform test command. We will not do that. We will initialize, because we just cloned this. So we'll run Terraform and that'll download our providers, and then we will get back on track with this. One thing I want to point out while this is running, we can see it's already picked up that it needs to initialize that setup helper module in our test. So it's actually going through the test files and making sure that we're pulling in and initializing those helper modules as well, not just the modules in our configuration. We'll give this one more second. While this is downloading, I guess I can go ahead and take it if there's any questions. Yeah. So the question was, is there a way to have tests run in parallel, or are they always in sequential order? I believe they're always ran in sequential order. That's a really good question, though, and I don't know positively if that's the only way to run them. I'll have to look into that, though. If you want, you can find me after the talk. I'll dig into some of the documentation and see if there is any mention of that. Any other questions? Sorry, what was that last part? Yeah, so is it actually like creating infrastructure and like deploying things to AWS? Yeah. Yeah, so to repeat the question, when you run Terraform test, is it actually creating infrastructure on the back end? And yeah, it is. So when you have that command field set to apply, that's telling it to go in, run and apply on your configuration. So in our case, when we run our test, it'll build the S3, it'll actually build the S3 bucket, it'll deploy the files up into AWS, and run all those assertions against that running infrastructure in AWS. Cool, so that bought me enough time, so thank you both. That was very kind of you. Now we will run Terraform test. Now what's happened is we've actually gone out, we've deployed that infrastructure into AWS, I'd set up the bucket, deployed those files, and it ran our assertions against the actual running infrastructure. For the next test that we're going to write, I want to rewrite that test where we're going to send a request up to the website and make sure it's up and running. We're doing on time. We're doing all right on time. All right. So I'm just going to copy this for the sake of not fat fingering something. And first, we're going to make our new helper module. So this is going to be the helper module that we'll call to actually use the HTTP data source to send a request to the website. And to do this, and get some more screen real estate here, I'll create a new directory in the test folder called final. And in there, I'll make a new file named main.tf. So this is actually the same example that we just saw in the slides. We have the endpoint variable, and then we'll use the HTTP data source to send a GET request to it. In our tests, I will copy this from the tutorial, and we'll jump back into our tests and add this new run block. So here, again, we are just running a plan since we'll know this information at a plan time. This data source is evaluated during a plan. We're calling that test final module that we just used, setting the endpoint to the output of our create bucket test, and then making sure it returns a 200. So let me save that. And we need to reinitialize our configuration since we just added a new module. I mean, these, even though they are for testing, they are new modules. And we'll rerun Terraform test. And again, fingers crossed, if I haven't messed anything else up today, we should see a third test, website is running, pass. So that sent a request up to the website and made sure we got that HTTP 200 back. All right, so I'm happy with those changes. I want to add that to source control. I'm going to commit this. Actually, first I'm going to add the new files and then commit it. And we'll just say we added the website is running test and push this up to main. So I talked a little bit about how we can also run tests up in Terraform Cloud. So before I do any of that, I'm going to hop over to Terraform Cloud, and I'm going to publish this module into my private registry. So I went a little faster. Let me go back. I went in the registry section, I went to publish module. Here's my GitHub account set up as a VCS provider. And we should see our Terraform AWS S3 website test repository. This is the one that we've just been working out of. So I'll choose that. And here's a new feature. I don't know that actually got highlighted as much as it should. But we've also introduced with this branch-based module publishing. So previously, if you've published a module, it'd be tag-based. So to release a new version, you would create a new tag in Git. Here, we're just tracking the branch and then making Terraform Cloud-specific versions. So my branch I've been working out of is the main branch, and we'll just call this 1.0.0. And I want to go ahead and enable testing on this. So I will publish that. And that'll just take a moment. And what we're going to do is I want to work through a scenario where tests are really handy, maybe not for new features we're adding, but just for maintenance. And I'm going to bump up the version of my AWS provider. It's a pretty common scenario, but a scenario I think tests can be really, really helpful for. So I have my module published here. Before we do any of that, we need to let Terraform Cloud know about the credentials to use when running tests. So in your module overview, under testing, there is the configure test option. And in there, we have this variable section. And this is where we can define environment variables specific for our module's tests. You've seen a little bit about it, but I have a little cheater helper script that will set all these for me. And we can see I've just set up the same environment variables that I would if I were setting these in a workspace or locally. I'm setting up my AWS key and secret. And then again, setting the region I want to run these tests in this case, US East 2. So let's go through that example of bumping the provider version. So I'll go back into my code in the terraform.ts file. And instead of 5.01, I want 5.16. Some great features in there. I want to take use of those. And we will bring this back up. Since we're upgrading a provider, we'll run Terraform init with the upgrade flag. We will spell Terraform correctly, not Terraform, Terraform. And we'll see if this takes just as long to download. We might take some more questions. But again, a use case I think is pretty common that we can lean on our tests to make sure that everything's working as we expected. Question? Can you save the variables at a global level? Right now, they're only for specific modules. I don't know, is Omar here? Okay. The person I was going to ask to answer that, I don't see it. I can ask him, and again, we can maybe get together after the talk and we'll track down an answer for you if that's in the future plans. But right now, it's only at an individual module. Yeah. When you're running the tests? Okay, so the question was, where's the state when you're running your tests? So in this case, it's stored in memory. One thing I didn't point out, by the way, is I think it might have been implied, but every time you do run Terraform tests, it will use that state to destroy all the resources automatically. But it is tracked in memory. So we do have it downloaded. That didn't take as long, thankfully. And I just want to rerun my test just to make sure that before I commit this up into my source control, everything's working properly. So I'll run Terraform test again. It's going to, again, go out, create the bucket. Looks like it created it fine. Website's running fine. It's going to tear it down. And I think we're ready to make these changes to source control. So I'll say git commit. Let me bring this to the top of the screen. Git commit upgraded AWS provider to 5.16. And when I push this to main, what's going to happen is we'll go back to our module overview. And we can see already Terraform Cloud has picked up that change since we're tracking any commits to that main branch. And it's already queued up to run our tests. If we look into our test results, our tests are running. We can see that commit message. In fact, if we look at all the tests, we can see the actual commit SHA, the branch it was from, who committed, and we can see all of our tests are green. So we like to see that. There's one other way we can run tests in Terraform Cloud, and that's by using the CLI, actually. So I'm going to do a little bit of destruction here. I'm going to go back to my code, and there's two things I'm going to change. I'm going to change the status code that we're expecting. In this case, I'll say 404, just something to break the test so we can see what it looks like when we have a test that fails for reasons other than credentials. And then I'm going to go in my main file here, and I'm going to, for my index file, I'm going to comment out this source field. Instead, I'm going to say content equals hello HashiCorp. And if you remember what we're testing for in the create bucket test, it's checking the contents, the hash of the file at www/index.html against what's up in S3. So in this case, the hashes won't match. I want to run these tests in Terraform Cloud, and there's a few reasons I might want to do that, right? So just like how if you're running applies and plans in Terraform Cloud, you don't have to have all your cloud credentials on every developer's laptop. Maybe there's networking reasons where your Terraform Cloud environment could reach something, but your development environment can't. In this case, my laptop's running really slow, so I'm just going to run up in Terraform Cloud. So I'm going to need the path to my module. In this case, I'm going to grab it just down here. So just the same path if I would include this module in another configuration. And I'll bring my terminal back up. And I'll say Terraform test. And I'll use the cloud run flag with a path to those tests. And what this is saying is upload my configuration, upload my tests of what's local to my machine, not what's in source control, and run that up in Terraform Cloud. And we can see we're getting some feedback on the CLI. And if we go over back to Terraform Cloud, we should see the tests are running again. And we should expect 2 failures from this. Saw a question. Test with the cloud agent. That is an architecture question that I don't know 100%. We'll create a little post group after this, but I will ask the person and we can get an answer for you right after this.
What happens if the teardown fails?
Yeah, so the question was, it's a really great question, thank you for asking it. So what happens if the teardown fails, which could happen for a number of reasons. I know I've seen my fair share of reasons why any particular Terraform command fails. So it will list out every resource that it failed to tear down. So you can go through and do some cleanup there. Cool. So we do see we have a couple failures here, and these are the failures we had expected. So our condition where we're checking the e-tag property of the index file in S3 doesn't match the content that was provided for it, doesn't match the file on our local machine. So that's one we expected. And then we're checking for a different status code. So we are getting a 200 back. That's actually good, but we said we want a 404 for some reason. And we can actually see here, let me zoom in a little bit. We can actually see here the value that the test got and compare it to what we're actually seeing. So in those in those error message fields, you can actually do a little bit of string interpretation if you want to say, well, I got this value and input a property of a resource or a data source. But in this case, for a lot of the time, Terraform will actually say, well, here's what I got, and here's what you expected. So some pretty cool information there. Just because I don't like leaving broken tests, I'm going to go back and fix those. So we will put our source back. We will change this back to a 200, and we will rerun the tests. So just another workflow that you could use if you want to run these tests. You can't run them locally, don't want to run them locally, but you want to run them up in Terraform Cloud. You can do that without making any of those changes in your source control repository. How many people saw Dan Barr's session a little bit earlier today on testing? Okay, a few people. One thing I didn't show in this workshop today is tests will actually run if you make pull requests against that branch that you're tracking. So if I made a pull request against the main branch, it would automatically run those tests from the PR as well. So probably a little bit more of a standard workflow there. Open up PR, test it, make sure it's good, and then merge it. But a few different ways you could put this into your workflow. Question?
Are the test results, essentially, whatever, available through API?
Are the test results available through the API? Yes. So we actually just published, let me see if I can bring this up. We actually just published this morning all the API documentation for tests, specifically in Terraform Cloud, which would be under API, private registry, and then tests. So we can get test details, I think is the endpoint that you're looking for. So yeah, everything that you can get through the UI, you can get through the API. That actually, I went a little fast. I apologize. So we can take as many questions as we have. Is this planned for Terraform Enterprise? So right now it's just Terraform Cloud. I believe down the road it will be in Terraform Enterprise. I don't know the timeline for that, but I think with most features, we'll implement in Terraform Cloud and then into TFE. Does it work with GitLab? I believe so. That's a really good question that I kind of wish I had validated before this, but yeah, I believe it should. Any other questions? Any? Yeah.
Is there support for variable sets instead of variables?
Yeah. So the question was, is there support for variable sets instead of just variables? Right now, it's just variables local to an individual module. Again, I think I don't want to comment too much on roadmap stuff that I don't know for sure. So I'm not positive offhand. I will look up that answer. I will contact the person who can answer that, and I'll let you know. Yeah. Is there okay, so the question was, is there a plan to support the public registry? Another question I'm not sure of. I apologize. Yeah, I think right now it's only supported in the private registry. I will take a look and see if I can get you that answer as well. So apparently we are going to have a sub session after this session. I apologize. Any other questions? All right. Well, thank you, everyone. Hopefully this was informative. Try out the new feature. It's available in 1.6. Everything you saw in Terraform Cloud is available today. Give it a try and let me know what you think. Thank you.